Langchain versus langgraph versus deep agents. If you are looking to build an agent, we recommend you start with deep agents, which comes batteries included, with modern features like automatic compression of long conversations, a virtual file site, and subagent spawning for managing and isolating context. Deep agents are implementations of langchain agents. If you don't need these capabilities or would like to customize your own for your agents and autonomous applications, start with langchain. Use langgraph, our low-level agent orchestration framework and runtime, when you have more advanced needs that require a combination of deterministic and agentic workflows and heavy customization. Langchain agents are built on top of langgraph in order to provide durable execution, streaming, human-in-the-loop, persistence, and more. You do not need to know langgraph for basic langchain agent usage. We recommend you use langchain if you want to quickly build agents and autonomous applications. To create an agent, use a method, create_agent, which accepts parameters, model, tools, and system_prompt. To run the agent, use the method invoke and pass a JSON with a key such as messages, which is an array of JSON with keys such as role and content. Philosophy: Langchain is driven by a few core beliefs. 1. Large language models. Foresteds are great, powerful new technology. 2. AMIs are even better when you combine them with external sources of data. 3. Airmans will transform what the applications of the future look like. Specifically, the applications of the future will look more and more agentic. 4. It is still very early on in that transformation. 5. While it's easy to build a prototype of those agentic applications, it's still really hard to build agents that are reliable enough to put into production. With langchain, we have two core focuses. We want to enable developers to build with the best models. Different providers expose different APIs with different model parameters and different message formats. Standardizing these model inputs and outputs is a core focus, making it easy for developer to easily change to the most recent state-of-the-art model. Avoiding lock-in. We want to make it easy to use models to architize more complex flows that interact with other data and computation. Models should be used for more than just text generation. They should also be used to architize more complex flows that interact with other data. Langchain makes it easy to define tools that IRACs can use dynamically, as well as help with parsing of and access to unstructured data. Core components are agents, models, messages, tools, short-term memory, streaming, structured output. Agents combine language models with tools to create systems that can reason about tasks, decide which tools to use, and coaching work towards solutions. Create_agent provides a production-ready agent implementation. An errand agent runs tools in a loop to achieve a goal. An agent runs until a stop condition is met, i.e. when the model emits a final output or an iteration limit is reached. Create_agent builds a graph-based agent runtime using langgraph. A graph consists of nodes, steps, and edges, connections, that define how your agent processes information. The agent moves through this graph, executing nodes like the model node, which calls the model, the tools node, which executes tools, or middleware. Core components. Model. The model is the reasoning engine of your agent. It can be specified in multiple ways, supporting both static and dynamic model selection. Static model. Static models are configured once when creating the agent and remain unchanged throughout execution. This is the most common and straightforward approach. To initialize a static model from a model identifier string, use create_agent. Model identifier strings support automatic inference. For example, GPT-5 will be inferred as OpenAI GPT-5. For more control over the model configuration, initialize a model instance directly using the provider package. In this example, we use ChatOpenAI with parameters. Models, for example, GPT-5, temperature, for example, 0.1, max_tokens, for example, 1000, timeout, for example, 30. The parameter max_tokens limits the maximum length of the response. The parameter timeout sets a time limit, in seconds, for the API request. If the model doesn't respond within 30 seconds, request fails. Useful for production systems and avoiding hanging requests. Model instances give you complete control over configuration. Use them when you need to set specific parameters like temperature, max_tokens, timeouts, base_URL, and other provider-specific settings. Dynamic models are selected at runtime based on the current state and context. This enables sophisticated routing logic and cost optimization. To use a dynamic model, create middleware using the @wrap_model_call decorator that modifies the model in the request. In create_agent function, indicate the parameter middleware equal to the list containing dynamic_model_selection. Dynamic_model_selection is a function marked by a decorator at wrap_model_call. The function dynamic_model_selection will accept two parameters such as request and handler. Pre-bound models with bind_tools already called, are not supported when using structured output. If you need dynamic model selection with structured output, ensure the models passed to the middleware are not pre-bound. Tools give agents the ability to take actions. Agents go beyond simple model-only tool binding by facilitating 1. Multiple tool calls in sequence, triggered by a single prompt. 2. Parallel tool calls when appropriate. 3. Dynamic tool selection based on previous results. 4. Tool retry logic and error handling. 5. State persistence across tool calls. Static tools. Static tools are defined when creating the agent and remain unchanged throughout execution. This is the most common and straightforward approach. To define an agent with static tools, pass a list of the tools to the agent. Tools can be specified as plain Python functions or effects. The tool decorator can be used to customize tool names, descriptions, argument schemas, and other properties. If an empty tool list is provided, the agent will consist of a single Armanode node without tool calling capabilities. Dynamic tools. With dynamic tools, the set of tools available to the agent is modified at runtime, rather than defined all up front. Not every tool is appropriate for every situation. Too many tools may overwhelm the model, overload context, and increase errors. Too few limit capabilities. Dynamic tool selection enables adapting the available toolset based on authentication state, user permissions, feature flags, or conversation stage. There are two approaches depending on whether tools are known ahead of time: filtering pre-registered tools and runtime tool registration. When all possible tools are known at agent creation time, you can pre-register them and dynamically filter which ones are exposed to the model based on state, permissions, or context. It is done using @wrap_model_call and middleware argument. Runtime tool registration. When tools are discovered or created at runtime, for example loaded from an MCP server, generated based on user data, or fetched from a remote registry, you need to both register the tools and handle their execution dynamically. This requires two middleware hooks. 1. Wrap_model_call. Add the dynamic tools to the request. 2. Wrap_tool_call. Handle execution of the dynamically added tools. You must create a class, for example, dynamic tool middleware, which inherits from the class agent middleware and implements the methods wrap_model_call and wrap_tool_call. Afterwards, in the method create_agent, you should pass the argument middleware equal to the list containing dynamic tool middleware. This approach is best when 1. Tools are discovered at runtime, for example, from an MCP server. 2. Tools are generated dynamically based on user data or configuration. 3. You're integrating with external tool registries. The wrap_tool_call hook is required for runtime registered tools because the agent needs to know how to execute tools that weren't in the original tool list. Without it, the agent won't know how to invoke the dynamically added tool. Tool error handling. To customize how tool errors are handled, use the @wrap_tool_call decorator to create middleware and try accept. The agent will return a tool message with the custom error message when a tool fails. Tool use in the React loop. Agents follow the React reasoning plus acting pattern, alternating between brief reasoning steps with targeted tool calls and feeding the resulting observations into subsequent decisions until they can deliver a final answer. System prompt. You can shape how your agent approaches tasks by providing a prompt. The system_prompt parameter to the method create_agent can be provided as a string. You are a helpful assistant. Be concise and accurate. When no system_prompt is provided, the agent will infer its task from the messages directly. The system_prompt parameter accepts either a straw or a system message. Using a system message gives you more control over the prompt structure, which is useful for provider-specific features like Anthropic's prompt caching. System message accepts the pentameter content, which points to an array of objects with keys. Type, text, cache_control. The cache_control field with type ephemeral tells Anthropic to cache that content block, reducing latency and costs for repeated requests that use the same system prompt. Dynamic system prompt. For more advanced use cases where you need to modify the system prompt based on runtime context or agent state, you can use middleware. The @dynamic_prompt decorator creates middleware that generates system prompts based on the model request. Name. Set an optional name for the agent in create_agent method. This is used as the node identifier when adding the agent as a subgraph in multi-agent systems. Agent equals create_agent. Model tools. Name equals research_assistant. Prefer snake_case for agent names. For example, research_assistant instead of research assistant. Some model providers reject names containing spaces or special characters with errors. Using LMOC characters, underscores, and hyphens only ensures compatibility across all providers. The same applies to tool names. Invocation. You can invoke an agent by passing an update to its state using the method invoke. All agents include a sequence of messages in their state. To invoke the agent, pass a new message. Result equals agent.invoke. Messages. Role. User. Content. What's the weather in San Francisco? For streaming steps and/or tokens from the agent, refer to the streaming guide. Otherwise, the agent follows the langgraph graph API and supports all associated methods, such as stream and invoke. Use Langsmith to trace, debug, and evaluate your agents. Advanced concepts. Structured output. In some situations, you may want the agent to return an output in a specific format. Langchain provides strategies for structured output via the response_format parameter. Tool strategy. Tool strategy uses artificial tool calling to generate structured output. This works with any model that supports tool calling. Tool strategy should be used when provider native structured output via provider strategy is not available or reliable. You should declare a class contact info which inherits from the class base model. In the method create_agent, set the parameter response_format to tool strategy contact info. Result will contain the property structured_response. Provider strategy. Provider strategy uses the model provider's native structured output generation. This is more reliable but only works with providers that support native structured output. From langchain.agents.structured_output import provider strategy. Agent equals create_agent. Model equals GPT-4.1. Response_format equals provider strategy contact info. As of Langchain 1.0, simply passing a schema, for example, response_format equals contact info, will default to provider strategy if the model supports native structured output. It will fall back to tool strategy otherwise. Memory. Agents maintain conversation history automatically through the message state. You can also configure the agent to use a custom state schema to remember additional information during the conversation. Information stored in the state can be thought of as the short-term memory of the agent. Custom state schemas must extend agent state as a typed dict. There are two ways to define custom state. 1. Via middleware, preferred. 2. Via state_schema on create_agent. Defining state via middleware. Use middleware to define custom state when your custom state needs to be accessed by specific middleware hooks and tools attached to said middleware. Defining state via state_schema. Use the state_schema parameter as a shortcut to define custom state that is only used in tools. As of Langchain 1.0, custom state schemas must be typed dict types. Pydantic models and data classes are no longer supported. See the V1 migration guide for more details. Defining custom state via middleware is preferred over defining it via state_schema on create_agent because it allows you to keep state extensions conceptually scoped to the relevant middleware and tools.state_schema is still supported for backwards compatibility on create_agent. Streaming. We've seen how the agent can be called with a method invoke to get a final response. If the agent executes multiple steps, this may take a while. To show intermediate progress, we can stream back messages as they occur using a method stream instead of invoke. Middleware. Middleware provides powerful extensibility for customizing agent behavior at different stages of execution. You can use middleware to 1. Process state before the model is called. For example, message trimming, context injection. Modify or validate the model's response. For example, content filtering. 3. Handle tool execution errors with custom logic. 4. Implement dynamic model selection based on state or context. 5. Add custom logging, monitoring, or analytics. Better integrates seamlessly into the agent's execution, allowing you to intercept and modify data flow at key points without changing the core agent logic.